All right, this is problem number 18, and it is a Bayesian analysis problem. So we're going to use Bayes' theorem. I've taken the relevant information out of the problem here, and we're told that a randomly selected driver has had an accident, and we want the probability that that randomly selected driver was from the 16 to 20-year-old category. So what we're really doing is we're just limiting the sample space. The thing that we want, the probability that the driver was 16 to 20, that is always going to be our numerator. So 0.06 times 0.08. And then our denominator is going to be all of the possibilities. So of the people who could have gotten an accident, could have been the 16 to 20-year-olds, but it also could have been the 21 to 30-year-olds, and it could have been the 31 to 65-year-olds, and it could have been the 66 to 99-year-olds. So we need to put in the denominator all of the possible ways we could have met the conditional statement, a randomly selected driver has had an accident. So if you churn this through the calculator, you get about 0.1584, I believe, and you can check the answer key to verify that. But let me give you a slightly better way to look at this problem, or at least a visualization that I think might help. So let's take our entire sample space and represent it as a box. And we're going to put some categories in this box. Okay. So suppose this little chunk on the left-hand side here, this is your 16 to 20-year-olds. So instead of calling them that, right, I'm just going to label the percentage. This is 8% of the total, 8% of the proportion of the total. And then we have 15% for the 21 to 30-year-olds. This isn't going to be quite to scale, but this is 15% of our area. And then maybe we'll do a little bigger one here. 49% of the area represents the 31 to 65-year-olds, and then the 28% lives over here. So that's vertically. And then horizontally, I'm going to put in the probability of accident. And I'm going to kind of exaggerate it so it's easier to see. So let's call this 0.06. And everybody on this side of the 0.06 is a probability or the proportion of the 16 to 20-year-olds that got in an accident. And then the other 94% that would be represented down here did not get in an accident. We do the same thing here for the next group, the 21 to 30-year-olds, which is 15% of the total, but only 3% of those people are going to get into an accident. So 3% that would get into an accident live here, and the 97% that don't get in an accident live here. And then we do the same thing for this category and the same thing for this category. So we'd have a 0.02 up here of getting in an accident and then not getting an accident here, and 0.04 representing that line. So since we're given the conditional statement, a randomly selected driver that the company insures has had an accident, we know that we are living in this part of the sample space, the part of the proportion that got into an accident. And then all we're doing to do Bayes' theorem and to create that large fraction that I made from the beginning is we're taking the area of this box and dividing it by the total area of all four boxes.